Thank you. So in this talk, you're going to get a quick introduction of Hex and how it works within Mix. Before we're going to dive into the architecture behind it, the community aspects of it, and how we handle security, and finally what features and changes we might be seeing in the future. So Hex is doing pretty well now. Just yesterday, actually, we reached 50 million total downloads. But looking at download statistics is not really a great way to determine users, though, because depending on how downloads are counted and so on, and how good clients are at catching packages, the numbers can be inflated. So I think looking at the change in downloads, how much they're growing, is a better way of looking at it. And we can definitely see some growth, as you can see. Just 1 year ago, we had 1 million monthly downloads, which I was very excited about. And now a year later, we're seeing more than 6 times that number. So that's very fun to see. To introduce Hex, we first have to talk about Mix, which is the build tool that ships with Elixir. And we use Mix for a bunch of things. It's more than just a build tool. You can think of it more like a project manager and a task runner, where one of the tasks is to actually build your project. It can also be used for scaffolding. For example, it ships with a task for generating new projects. And the web framework Phoenix and Ecto, which is a database library, also includes generators for creating things like database migrations, controllers, and so on. It also, of course, does more common tasks like it compiles your code, it can run tests, and it handles your dependencies, which is what we're going to be focusing on here. So here you can see the mix file, or the mix.exs file. This file configures your project, and it's a central part of Mix. And files ending in .exs are script files, which means that they are not compiled to Beam files. They are just evaluated when they are run. And Mix will load this automatically when it exists in the current directory, and it's what defines your project. And we can see that this mix file defines a single function. That's the project function, and it's what's configuring your project. And here you can see a minimum example of that. And this is also where you would list your dependencies, compiler options, and anything else. So let's look at the actual dependencies. So out of the box, Mix supports JIT and path dependencies. A path dependencies is just a project that exists on your local file system. And path dependencies are useful when you're working on a new feature or maybe fixing a bug or something like that, and you want to see how it works before, in a project context, before you actually push the change to your version control. And we can see here that we have a poolboy dependency from JIT and an Ecto dependency. So for poolboy, we have defined that we're going to fetch it from GitHub and the name of the repository to fetch it from. For Ecto, we haven't defined how to fetch it, which means that Mix will fall back to an external package manager that is plugged in. And if you have Hex installed, it will be used to fetch the dependency. So we have a bunch of tasks for getting, updating, and printing your dependency, as you can see here. Deps get, deps update. We have tasks for listing your dependencies and so on. And in Mix, we have something called the dependency converger. What it essentially does, it's that it resolves your Mix dependencies. It does not resolve actual Hex packages, but because that's handled by Hex itself. And it performs 2 basic tasks. It converges dependencies and sorts them. And what converging means is that we can take 2 dependencies with the same name and merge them into a single one. And we need to do that because the runtime that we're running inside can only allow one application with the same name. So you can have two dependencies that actually depend on the same dependency. So you can have, for example, you can have two different dependencies depending on Poolboy, for example, and we need to make sure that they're compatible. And we do that by checking just if we fetch it from the same place. So both dependencies has to be defined as being fetched from Git, for example, from the same repository, and use the same branch or tag or anything like that. If there are conflicts, we're going to complain about it, but you can always override that. We also have the mix log files, and what it does, it's essentially the core feature of it is that it ensures repeatable builds. And a repeatable build ensures that all developers, and when you're deploying, if you're not using releases or your continuous integration, all those places are going to get the same version of all your dependencies. So this file locks your dependencies. So here we have cowboy, cowlib, ranch, and poolboy. And it defines that, so some of these are from Hex. It defines the Hex version, the checksum of the Hex package. For poolboy, it just defines where to fetch it, and the checksum, the JIT reference to use for it. And for this to work, it's important to remember that you should always commit this to version control to ensure that all users of a project are going to get actually the same version of your dependencies. So that was repeatable builds. Mix can also compile and load and work with non-Elixir projects as long as they follow the standard OTP conventions. So it handles rebar and rebar 3 projects, and any project that has a make file it can compile. And Mix also knows how to read rebar.config files, so it can get. So if a rebar project has dependencies, it can actually get those dependencies and fetch it itself, and then just use rebar to compile those. And this is really great because it means that we can use all of the existing great libraries that are already out there. So that was a bit about Mix. Next, we're going to talk about the architecture of Hex, and more specifically about, well, we're going to focus on the specifications and sort of talk about a bit about how Hex works internally. The two main parts of Hex are the service, the repositories, and the clients. But they are just implementations of specification, and that's what Hex really is. It's specifications and then separate implementations. And these specifications are fully documented, so anyone who wants can build their own repository and they can implement their own client. And the specifications specify things like this, the structure of packages, what endpoints the repositories need to implement, the layout of registry and the layout of the registry, the administrative interface, which is where you push packages and so on, which is the HTTP API. And you can also use the API to browse and find packages and get metadata and so on. So let's start with the package structure, and this is what it looks like. It's a single uncompressed tarball. It contains 4 files. The version file, which just contains a single number defining the version of the package. We have a metadata file that has the metadata, like the package name, version, description, and so on. And we'll just take a closer look at that in a bit. The checksum file has the SHA checksum of all the files except for the checksum file. And finally, we have another nested tarball that is compressed, and that contains all the files that the user decided to include in the package. So, like the mix file, the rebar config files, source files, configuration files, and so on. Anything that is needed to run and build a package. So this is what the package metadata looks like. It's just an Erlang term file. This was initially Elixir syntax, but when we started to realize that Hex could be used by the whole beam, we changed this to Erlang, so that other build tools like Rebar 3 could read and write it. And again, this is just some basic information like name version, links to, for example, GitHub, the dependencies of the package, and so on. The repository needs to implement 3 endpoints. It's very straightforward. It needs to have a registry file, a signature of the registry file, and all the package tarballs that it has. We're going to take a closer look at what the registry currently looks like. So it's a single ETS table that we have serialized to a file. And here you can see like an example content of the registry. So for every package, we list all the released versions of that package, and for every release, which a release is a version package pair, and here you can see Ecto 0.1. We list the dependencies and the version requirements on those dependencies. And in the mixhex client, we need to fetch the registry every time we run the dependency resolution, so that we can find all the most recent packages. And today we have about 2,700 packages and over 12,000 releases. So this file is almost 3 megabytes now, and almost 1 megabyte when compressed. And this file size is starting to become a problem, since we have to fetch it so often. And later in this talk, we're going to look at a new proposal for registry format. So a core part of the package manager is the dependency resolution. And this is the basic algorithm for it. So we take the dependencies from the mix file and add those to the list of pending requests. Pending requests are what we call dependencies that we have not yet processed in the logic here. So we take the first pending request and we try to find the latest matching release, so the latest version that matches the version requirement. And we compare this against the packages that we have already seen as activated. So those are packages that we have determined a version for. If we don't find anything matching, we need to backtrack to an earlier state. So each time we activate a package, we save the state so that we can later go back and change something to try and make it pass. If we find a matching version, we can actually activate that package and try to use it. We add the children of that package to the list of pending requests so that we're going to process them later. And as I said, we save the state at this point for later backtracking. And when we no longer have any pending requests, we're going to see this as the list of packages and versions to use. So this algorithm will always find the best solution. So it's always going to find a solution if there is a solution, and it's always going to find the best solution, and that is the latest version of a package. Or there can be multiple best solutions, and then it's going to pick one of those. The problem with this is that it can have very high time complexity. With this logic, and we have some optimizations for that, but sometimes we find bugs where this will hang for longer than we want. It's also kind of tricky to find if there is no match, it's tricky to find where it actually failed because it tries everything, right? So it's hard to find where it actually was a version incompatibility. But what we do now is that every time we backtrack, we save the state at that location and while the match failed, and we use that to present to the user to show one of the possible failures. So that was a dependency resolution. Let's quickly look at the systems that build Hex. So the main repository for Hex is hex.pm, and it has three major components. All of this doesn't have to be implemented to have your own repository. You only have to actually implement the repository endpoints. But HexPM also has a website, and it has Hex Docs, which is for hosting documentation. And the website and HTTP API runs on Heroku. The repository and Hex Docs are just static file hosting, so we have them on Amazon S3. And they go through Fastly for content delivery, which are very kind of sponsoring for us. So let's take a look at some of the community and ecosystem aspects of package managers, and more specifically Hex. So first off, this is the website we have. We recently got a new design for it, which I am very glad for. The last one was designed by me and not very pretty. We have on the website, we have daily download statistics for the whole repository, and you can't see that here, but we also list most popular packages, new packages, and those that were recently updated. You can search for packages. You can search for package name, of course, and we have full text search on the descriptions. This is not great, but we're looking at adding maybe some kind of categories or a tagging system so that it's easier to find packages. And there are a few people that are working on improving the full text search as well, which is very nice. And this is an example of what a package page looks like. So here we have a very popular package, the web server Cowboy. And here you can find the releases of a package, the download statistics for it, links back to the GitHub repository. And it also shows which build tools it's made for. So not the build tools it supports. So here, Cowboy shows with the rebar and make tags. And that means that it has a make file and it has a rebar config file in the package. But all the major build tools, Erlang make, rebar, rebar 3, and mix, can build this project. So mix, for example, as I said earlier, can build rebar projects and can build make projects. Rebar can, of course, build itself and make as well. And we'll also show small snippets that you can paste into the configuration of your favorite package manager. Of your favorite build tool. And the three main build tools that we support today, or that support Hex actually, are Mix, Rebar 3, and Erlang Make, and they both support fetching and using dependencies and actually publishing dependencies. But having all these build tools use the same package manager and be in the same ecosystem doesn't really mean much if they can't use each other's packages. And Elixir has been lucky because we've for a long time have had support for compiling and using rebar and make projects. I think Erlang Make has plugins for compiling Mix, and I think it supports rebar out of the box. Rebar 3 actually just very recently got a plugin for compiling Elixir projects, which is very nice. But Erlang is also easier to use from Elixir than the other way around. And it's nice that Rebar 3 and Erlang Mac has plugins to compile Elixir projects, but I think there's still ways that we can improve this, and we need to work on this from both sides. So Hex docs, this is where we host the documentation for Hex packages. This is an example. This is Ecto. This is an example of the documentation for an Elixir project. Acebroker is an Erlang project, and we support that as well. Using the documentation part when you publish a package is completely optional, and Elixir developers seem to use it a lot, but Erlang developers less so. And actually, if you remember from Fred's keynote yesterday, it seems that even Rebar 3 core committers doesn't really bother doing it. So in Mix, we actually recently started to automatically publish docs when you push your package, and maybe Rebar 3 should do something similar so that actually people are forced to use it. And the documentation is versioned, so you get so you have separate documentation for each release, and we link to these docs from the package page on the website. And as I said earlier, HexDocs is just simple static file hosting. So the user's build tool or some kind of plugin for the build tool builds the documentation, puts it in a tarball, and pushes it to the API server that then later puts it on HexDocs. So this is very basic. I built this quickly. It works, but it's rudimentary. If it was more sophisticated, we could get more fancy. We could get full text search or documentation and so on. So, if you want to work on this, I will be very glad to help out with that. In the Mix build tool, we can also use Hex to install eScripts. And for those of you who may not know what an eScript is, it's basically an executable that runs Erlang code containing it. So it's a small script file and a zip file containing precompiled Beam files. And we can actually use the existing functionality in Mix to fetch dependencies to fetch eScripts. Well, it doesn't actually fetch eScripts. It fetches a project, and then it knows how to build this project and how to build an eScript from it. So it does that, and then finally installs it in some location that is hopefully in the user's executable path. So for better or worse, we can sort of get people installing application executables through Hex. So to kind of summarize the community and ecosystem parts of this, we can talk about what we get out of Hex and what we get out of package managers. So one nice thing is that we get a single location to find libraries and documentation for those libraries. And we have stuff like download statistics. We can see how actively a package is used. We have links back to GitHub and stuff like that, so we can easily find where it's being developed and help out with that. And another thing that at least I think is great is that Hex forces, or Hex PM, which is the main repository, forces a single name for a library, and that improves the collaboration on it. So one issue I've seen in the ecosystem is that people are using a library and they like using it, but they find this little bug, and they fix that bug in their fork of it, and they don't really bother contributing back to the main repository, or maybe the original maintainer is not really active anymore, so the pull request just sits there. And from this, a lot of forks are born. And when I come in as a new user, some of these forks may be more actively maintained, some may have died off, but when I come in as a new user, it's really hard to find which is actually the library to use. And having a single location, so having a single name for a package actually means that people are more encouraged to collaborate and contribute into a single place. So we get more, hopefully more collaboration, less forks, and I think it also contributes to cross-beam language use. And you can of course get all of the things that we talk about here without a package manager, but I really think that a package manager helps pushing it in these directions. Other nice things is that we can contribute back to the OTP team, for example. So hopefully they can use Hex to like Ken was talking about just recently about splitting the OTP project into smaller applications. So maybe they have less of a workload and easier to use, essentially. So let's talk about what goes into securing a package manager. So let's start with what we actually need to secure. First off, of course, we need to secure the servers and the other services that are used to run HexPM. So for example, Heroku and Amazon and Fastly that we use. And for this, there's really nothing much more to it than we try to follow the best practices, use long random generated passwords, two-factor authentication when it's available, and so on. Other things that we need to secure is the actual binary that is the Hex client. And this is from Mix, by the way. And Elixir ships with a public key that we use to verify the Hex client that is installed. So for every new Hex release, we sign it by the corresponding private key that we keep offline. We also need to secure the HTTP API, the integrity of the registry of packages, and also try to help out with securing users' API keys. I'm going to look at that in more detail in just a bit. So to secure the website and the API, we of course use HTTPS. And the Hex client uses this API to publish packages and to fetch from the repository. And when we do that, we of course need to connect over HTTPS. And HTTPC, which is the client that the HTTP client that ships with OTP, lets us do this. But out of the box, you don't really get all of what you commonly see as HTTPS. In fact, it's quite insecure to just use the HTTPS that you get for free. So OTP has the SSL library, which helps us connect over SSL, and it encrypts the connection, but it never actually checks that the server that we connected to serve the correct certificate. So we have to do our own hostname verification to actually check that if I connected to HexPM, if I want to connect to HexPM, HexPM actually served a certificate that says I am HexPM. Another issue is that you have to, well, these are not really issues, these are just things that you have to build yourself. Is that you have to handle partial certificate change yourself. And to just quickly explain what a certificate chain is, it's in public key infrastructure, which we use to secure HTTPS connections in browsers and so on. When we connect to a server, they send back a certificate that tries to prove who they are. And so we have certificate authorities that sign this certificate. And they can be companies like like Semantic, GoDaddy, or foreign governments, and people that we trust. And to actually go back to this issue, the server sends a chain of signed certificates that so you have your own certificate at the bottom, and it's signed by a certificate authority, and it itself can be signed by another certificate. And you have to yourself look into the certificates chain and check that one of those matches a certificate that you trust in your store. And the SSL application doesn't do this by default, but it's very nice that we get the hooks and we get the callbacks to be able to implement this ourselves. Right. So I mentioned certificate stores. You have to bring your own. So OTP or Elixir that we use doesn't provide a certificate store, and there are no bindings to actually find a certificate store on the system. So like the one that you get with your operating system. So you have to provide this yourself. We use the Mozilla certificate store, but we have to bundle this with the installer, and we have to make sure that it's secure, that we fetch it securely, and so on, that we can ship it to client security, and we have to make sure that it's up to date, because these things, they change from time to time. And we also had some issues with HTTPC. It has some weird behavior in some places, which is not common. Well, it follows specifications very well, but sometimes there are things that are not specified in specifications, which is sort of common what HTTP clients does, and it may not follow those conventions. And it also has some race conditions that have been reported and known for some time. So it just doesn't get as much love as it could get. So a lot of these things I had to figure out for myself. Other things were figured out by other people. So for example, SSL Verify Fun by Deadtrickster implements the hostname verification, so I could look at that, and it was very nice. Sometime, I don't really know when, but I think this year, maybe late last year, we got this Erlang Certify package, which sort of just brings your, which adds a certificate store, which is built by Benoit, that does the Hackney client. And you may wonder why we don't use a more commonly used HTTP client that may be more actively maintained. And the big problem that we have is that Hex runs within the Mix application, well, within your Mix project, and you can run your application in the same virtual machine that Mix runs in. So if we, for example, would add Hackney as a dependency, that would conflict with the applications that the user has loaded in the same virtual machine. So we also have to secure the integrity of the registry and packages. So the registry is signed with HexPM's private key, and this is an online private key, and the reason it's online and not offline is because the registry changes multiple times per day, so it's not really feasible to have it stored offline. So that's how we verify the integrity of the registry. We also have to verify integrity of package tarballs. And we can do that because the registry includes package checksums, and since the registry is signed, we can also verify that the packages have not changed. The Mix lock file also includes checksums, so that can also be used to not realize a verification, but at least you would know if the repository for some reason changed the package checksum or changed the package that you have already locked. We need to secure authentication. So we have bcrypt hash passwords. They're basically only used to get API keys that you use to communicate with the API with. Keys. So just until recently, we had the keys stored in plain text on the user's computer. Now we encrypt it with the user password, and by encrypting the API key on your machine, we are protected against a vulnerability found in NPM earlier this year. And the vulnerability report describes how a worm can quickly spread inside of a package manager. Well, inside of the repository of a package manager. So this was described for NPM, and in NPM, when you fetch a package, there is some code executed, which is part of the package. And we have the same thing in Hex and with the mix.exs file, which is just code that is run. Rebar has the same thing with the rebar config script. So this is an issue because someone can create a package which only when fetched, not when run, finds the user's local API key, finds all the packages that the user has publishes in a new version of all of those packages with itself as a worm, and this can very very quickly spread across the whole repository. But just by encrypting this with the API key, we are protected against this. We're also adding two-factor authentication that would also help with issues like this. Another issue is typo squatting. So there was a paper that came out this summer that describes an attack on Package Manager where a malicious user can find popular packages, find common typos for those packages, and publish packages with the common typo names with malicious code. And we have very simple protection against this right now. We just have a nightly job that runs every 24 hours that checks the similarity of new packages that day against existing packages. And if there are too similar, admins are notified and they can do a manual review. So you may have heard of LeftPad. It's a package in NPM, and it was a bit of controversy around this this summer. And so to kind of explain what happened was that there was this package LeftPad which had a single function. It padded a string with a certain number of characters. And it was very dependent on. There was a lot of packages that depended on this package, and it had over 100,000 downloads, or almost 100,000 downloads a day. So very, very active. And the package owner suddenly removed this package from the repository, which subsequently broke large parts of a large part of all packages inside NPM. And to fix this issue, the admins just said, well, they just decided that they would take ownership of the package, and against the original owner's consent, they republished the package to fix this. And the main takeaway from this is that we should limit what users are allowed to do. One user shouldn't be allowed to break other users' projects, right? So this comes back to the repeatable builds that we talked about earlier. If my project worked last week and I didn't make any changes to it, it should still work today, right? And in Hex, we don't have this issue because we limit these kinds of things. You cannot change or remove a package after it has been published. So the main issue security-wise with Hex is that we do not yet have user-signed packages. The only signing we have is by the repository, so the repository is a single trusted entity. And there are a few different solutions for this. We have public key infrastructure, which is the certificate, which is similar to the certificate authorities that I was talking about later. This is not really great because if HexPM is this certificate authority, we still have the same issue that HexPM is the single trusted entity. There's also the web of trust like GPG and PGP. The main problems with that is it's not very user-friendly. It proves that you are a certain person, but it's hard to connect persons and packages. So someone will have to do that linkage, and the person that does that linkage is, again, a single trusted person. And for user-side packages to work, it of course has to be secure, but the other thing it has to be is very easy to use, because otherwise people just won't use it. And we've seen this in other package managers that have implemented signing, which was not really easy to use, and people simply do not use it. So there's not a silver, as far as I can see, there's not a silver bullet for this, but if someone has ideas, I'm very interested to hear about it. So before we end the talk, let's quickly talk about the future of Hex. So we have not yet reached 1.0, where we do not have a stable API yet. And what's needed for that is we need to make sure that the specifications are stable. I feel that's pretty close right now, and the HTTP API needs to be stable, which is part of the specifications. We also need to fully implement the new registry format, which I'm going to talk about next, and make sure that we are happy with that. So I mentioned that we have some issues with the current registry today. It's a single ETS files. It's a single ETS files. It's almost a megabyte compressed. It grows with about 20 kilobytes a week. So in a year, it will be double this size. The other problem with the ETS file, it's kind of tricky to do forward compatibility. So we might want to add things to the registry, and we don't want to break all existing clients. And we do that by using lists and only matching on the front-end list, but it's kind of informally specified, and there can be bugs in clients that would suddenly break them. So we have a proposal for a new registry format, and the fix for the scalability problem with the file size is that we split it into one file per package. So we have a single file. So for Ecto, for example, you fetch a single file just for Ecto and get the versions and dependencies of Ecto. We also have index files, names and versions that list the names and the versions of packages. Those should not be used. Those would have the same scalability problems, so they should not be used for clients. They should only be used for things like mirroring. And we use protocol buffers to ensure forward compatibility and to get a somewhat compact representation of the registry. And for mix, at least, we still use a local ETS file as a cache for the whole registry. We're also going to add namespaces. This would allow private packages. And the issue with namespaces is that I don't think it should exist for public packages on HexPM, because we would have the same issue with forks again that I was talking about earlier. So I think this should maybe only exist for private packages, and if people want to have their own repositories, they can use namespaces for that too. We're also adding package retirement. So this is if you find a security issue in your package, if you want to deprecate it, rename it, or so on. You can retire the package, and you will get a warning when fetching it. The package will still be available because we, of course, need to make sure that we still have repeatable builds. And to finally round this off, these are some of the current issues that I see in Hex that needs to be improved and that we're trying to work on. First off, package signing. If you have any ideas, I'd be happy to hear them. We have the issue of some existing Erlang packages that are very highly dependent on are not on HexPM because either the maintainer is not active anymore, or they're not interested in using package manager. They use a build tool that does not support Hex, or they just don't care, right? So that's a problem that we have, and I think that's mostly an onboarding problem, and trying to help people see the benefits of using a package manager. The other issue, which Fred mentioned in the keynote, is private repositories, which we are currently sort of investigating the best way to do that. I know that Reba 3 has a solution for it, and if that works out well for them, we might do something similar for Mix. So this might not be an issue that has to be solved by the repository, but the specifications. Maybe clients can have their own rules for how to use private repositories. And so I'm not sure if we have time for questions, but if we do, we don't have time for questions. So thank you.